I hope by this point you feel comfortable making orbital configurations and electron configurations. So now let's practice with quantum numbers. You've already looked at the theory of quantum numbers, but now that we know more about electron and orbital configurations, we can apply the concepts and the ideas that we learned about previously. Here is the orbital configuration for bromine that we drew out earlier. I might ask a question like, what are the 4 quantum numbers for the second electron of bromine? And if I did that, I'd be asking the question about this electron right here. This is the second electron that I added to my orbital configuration as I was drawing out the orbital configuration for bromine. So what are the 4 quantum numbers for this electron? Okay, so when I ask these questions, what I'm asking is N, L, imps of L, and imps of S. What are these quantum numbers? So the first quantum number is N, your principal quantum number. Remember, your principal quantum number tells you your energy. So our energy is 1, and so that's my principal quantum number. Next is L. That is my subshell. That's my shape. If I have a shape of S, then my subshell is going to be 0. So it is 0. And then imps of L. What is my imps of L? It is also 0. Because remember, I can go from -0 to +0, so my only option here is 0. And then what about my spin? So remember, an upward spin is +1/2. A downward spin is -1/2. So my imps of S is -1/2. And these are my 4 quantum numbers for my second electron of my bromine orbital configuration. Let's do another one together. Let me pick a harder electron. How about this one right here? So what number electron is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my 10th electron. So what are my 4 quantum numbers for this electron? N, L, imps of L, and imps of S. So my N is once again my principal quantum number, which is 2. My P tells me that my L is going to be 1. Now what orbital is it in? Remember, imps of L goes from negative to positive. Remember this slide? Negative, so the first orbital is negative, to 0 to +1. That's all we're going to do. So I'm going to write -1, 0, +1 right here. And so that tells me the orbital that it is in has an imps of L of +1. And then my spin is downward, so once again I have a -1/2 spin. So these are my 4 quantum numbers for the 10th electron. All right, I hope you're getting pretty good at this. So let's pick out this electron. What number is it? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 23, 24, 25, 26, and 27. So this is my 27th electron that I put in place. What are the 4 quantum numbers for that electron? N, L, imps of L, and imps of S. So N is 3. If it's a D, then it's going to be 2. And then I go from -2 to +2. So that means it's in the -1 orbital, and my spin is -1/2. And those are my 4 principal quantum numbers. Or not principal quantum numbers. Principal quantum number is just this one. Those are my 4 quantum numbers, excuse me. Let's do one last one. How about we choose one of these positive ones? Let's choose, how about another P? Let's choose this one. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So this is number 31. So the 31st electron. What are its quantum numbers? N, L, imps of L, and imps of S. So your N is 4, your L, P is 1, So 1 imps of L goes from -1 to +1. So it's -1, and my spin is +1/2. And those are my quantum numbers. So you can do this for anything, but notice every single electron has a different set of 4 quantum numbers. And this is important. These are like the address that identifies the electron. Just like your address has included a number, a street name, a zip code, a city. This is the address. And so figuring out and identifying the 4 quantum numbers for any electron is pretty easy. You just got to get used to it and you just got to practice it.